Check, 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 check. Well, hey everybody, welcome to our live webinar. This is a webinar technical series that we're going to be doing on a monthly basis, live on YouTube, and then we'll repost the videos so that you'll be able to see them whenever you want to watch them. But our goal with these webinars is just to cover a few topics, have some interaction, and answer any questions that you have about the topics. So today we're going to start with GD&T. GD&T is geometric dimensioning and tolerancing. So we'll be talking about how to do that in SA and just show you some of the tips and features that might help you to do GD&T easier in SpatialAnalyzer. So just a little bit about myself. My name is Caleb Canal. I am an applications engineer for New River Kinematics, and I'm based in Tyler, Texas. And just as a side note, we're having a wonderful sunny day here in Tyler, Texas. So I want to point you in the direction of our website. First of all, if you haven't been there, check it out at kinematics.com. A lot of great information there. We'll also notice that there is a section for these live webinars, which we'll be hosting on a monthly basis with multiple different topics. So check that out with the live webinars. Also, if you'd like to meet us in person, New River Kinematics will be at Control May 5th through the 8th. And we'll also be at CMSC, which is in New Orleans this year, and that's July 20th through the 24th. So be sure to make it there to those. Those are always really, really incredible resources for portable metrology. And we'd love to meet with you in person and talk about SA and maybe help you solve any metrology problems that you have that we can help with. So with that being said, let's get started into GD&T. All right, so I've got SpatialAnalyzer open here. And let's just talk a little bit about the new ribbon bar. Let me make sure my audio is working. Can you guys hear me now? Let's see. Okay, I've got Matt who's following along on the chat. He says, Matt says he can hear, so I think we're good. Okay, all right, yeah, so I've got the chat window open, and if you do have questions during the webinar, go ahead and type them in there. Bobby Martinez will be following along, and he will keep track of those, and we'll try to answer some of those questions if you have any GD&T related questions at the end of the presentation. All right, so let's make sure we're back on track here. Okay, so you guys can see my SpatialAnalyzer window, and you can hear me. All right, let's get this going here. All right, so in SpatialAnalyzer, any version that you're using after November of 2019, you're going to have the ability to show the ribbon bar. And the ribbon bar is our fantastic new interface. We sort of co-locate and group things together so that they're easy to access and really get rid of that really deep menu structure. So as it relates to GD&T, there's actually a GD&T tab in the ribbon bar. And if you don't see the GD&T build section over here, just select the build button and you'll see that over here on the right hand side. So first of all, let's talk about getting started with GD&T. If you have a job file or a CAD model that includes GD&T, then one of the great things about SpatialAnalyzer is that all of those CAD native formats are supported. So let's go ahead and import a CAD model that has GD&T built in. So I'm just going to go to the menu button and select import and go to auto import. And then I'm going to import this sample file called SA demo part. And if you've been a part of any SpatialAnalyzer demonstrations, you'll probably be familiar with this little metal piece that we show. And so right now it's going to bring in the surfaces and any annotations that are available in SA as well. So if we zoom in here, you'll be able to see that we've got our surfaces. Let me switch to solid rendering. There we go. Oh, interesting. Got some extra surfaces in there. Okay. So we've got our surfaces and we also have our annotations. And if you're using a CAD model that has annotations built in, that's the great thing is all the CAD translators are included. So just drag and drop them right into the software and you'll get your annotations there. Now with GD&T in SpatialAnalyzer, the annotations are the first step. Those are going to show you, they're going to actually define the checks that need to happen. And they're going to show you what surfaces those checks happen with. So if you have annotations, you're already most of the way there. The next thing that you need to do is take your annotations and make feature checks. So a feature check in SpatialAnalyzer is really just a way of grouping the requirements, which are shown in the annotation, and all of the points that go with it. So a feature check is how we evaluate the data that's been associated with that GD&T. So let's go ahead and let's talk about a situation where you don't have a CAD model that has model-based definition built in, or you need to build the GD&T checks yourself. And so in order to do that, I'm going to start a new job here, and we're just going to build this from scratch. So I've got a new job, and again, I'm just going to import the CAD model without any annotations built in. I'm just going to bring in the surfaces. So I'm going to select Import, Auto Import, and go back to my demo part here. But I'm going to exclude everything except for my two surfaces, which in this case are called base and vertical. So now we've got our CAD model here. Go ahead and solid render. We've got our CAD model here, and we're going to be building our GD&T annotations. And this is really pretty simple. Like I mentioned, select the GD&T tab, select Build, and then you're going to pick the annotations that you want to build right from the menu over here on the right-hand side. So for instance, in this particular part, let's select Datum A, and we're going to be picking this, connecting it to CAD faces. Now, it is possible to do GD&T in SpatialAnalyzer without CAD. It's not all that difficult. You just have to locate your nominals where they would be with respect to each other. But if you have CAD, it really makes the whole process simpler. And for the sake of time today, this webinar is going to run about 30 minutes. We're going to just start with the assumption that you have CAD. So in order to create your GD&T, first of all, we'll start with datums, and we'll select our datums on our part. So I'm going to be picking CAD faces as my nominal feature type. And I'm going to pick the datum, just click on the button, and then just click on your CAD model where you want to represent that nominal datum. So I've selected the top surface here as datum A, and then I hit enter, and you can see I can get the annotation on there, and it shows up easy to see. Then we'll select datum B, and we'll place datum B right here on the back side, and then we'll select datum C. And you'll also note that as you pick datums, you can actually pick multiple faces for those datums. So for datum C, I'm picking a face up here, and I'm picking a face down here, and then I'll hit datum C. Okay, so it's also possible to drag these annotations once you've created them. You can drag them so that they're shown in a way that makes a little bit more sense to you, or that it's not on top of your part. And you just do that by hitting this placement control button in the menu. And once you do that, you can move them around till you get something that you like, and then you can hit save all, and it'll save those annotations. Okay, so once you've built your datum reference structure, you've got your datum selected. And again, I've selected flat surfaces, but there's no reason that you can't select circular surfaces as well. So we'll call that datum D. And you can even do slots. And I'm just making sure to pick, when I pick these, I'm making sure to pick all of the CAD faces that are associated with that particular feature. and that will help you be able to filter out your data if you want to automatically associate your data to those feature checks. So we've got some datum structure in there. The next thing is to create our feature control frames. So if you're familiar with GD&T, you know that the way that a feature is defined is by using a feature control frame. So in this instance, I'll show you what that looks like. We'll set a tolerance here. So we'll go in at 0.005, so our tolerance of 5 thou, and then you'll set your datum reference scheme. So we'll call this to datum A, B, and C. And again, when you're selecting your datums, you don't have to put any spacer or anything in there. Just type in the letters that represent the datums, and you're good to go. And then you'll see all the types of GD&T checks that you can perform. There's form checks, orientation checks, and location checks. And for this particular one, let's go ahead and go a true position check. So I'll pick that, true position. And then I'll just click right inside here where I want to do a true position within 5. And I'll hit enter, and then you can see we get our feature control frame there. For the next one, I'm going to do a true position for these 4 holes, and I'm going to have a true position for the holes themselves as well as for the pattern of holes there. So in that case, what we'll do is a composite true position. So again, I'm going to keep it to 5 thou, but just to switch it up a little bit, we'll go to A, B, and D here as our datum scheme. I'll select composite true position, and then I'll just pick all of the faces inside these 4 holes. And you don't actually have to pick them in any particular order, just as long as they're all selected. So I'm picking all the ones that I can see from that one orientation, and then going back and picking that 4th one, which is a little bit more challenging to see there. So now I've picked that, and you can see that I have a composite true position. Let me do one more. We'll do a surface profile for this large piece back here, and we'll do that surface profile within 10. To A, B, and E. And it's also important to note that for features of size or for datums of size, you can add material modifiers to the tolerance and to the datums category by just adding an @M or @L to note that you want to add a material modifier. So if you type in A, B, E @M, then you'll get a maximum material condition on your E datum. I'm going to leave that off for right now, and then I'm going to select surface profile, and I'm just going to click on the CAD face right there. Let's drag these out a little bit to make them a little bit easier to see. There we go. And we need to make one modification to our true position, our composite true position. You can see that we've got a tolerance of 5 thou to A, B, and D. And then what we need to do is add a datum to our lower frame there that lets us know what reference we need. And we'll probably change the tolerance on that as well. So I can get to that just by right-clicking and selecting Properties. And then you'll see my Annotations dialog pops up. And it's showing us that for this composite true position, what we need is our primary on the lower tier. And we want to change our tolerance on the lower tier as well from 5 to 10 thou. So now we've got all of our annotations set up. We just need to create feature checks from those. So we'll make feature checks, and then you'll notice that we're already set up to use the inspection bar to go ahead and measure these datums and features. So that's one of the benefits of using the inspection bar is it shows you exactly the things that you need to inspect, and we'll check them off as you move through those if you're measuring live while going through this. And if you don't see the inspection bar over here, you can just right-click in at the top of any of these toolbars and select inspection bar. And then you'll see it right there. So setting up GD&T is really pretty simple. Another thing that might be of interest to you is when you do have a feature check or an annotation to a feature of size, SpatialAnalyzer can automatically add the dimensioning tolerances to that as well. So let's say we have a true position within 5 to A, B, and C, and we're going to put a true position on this whole location here, and that is going to be 5 thou at MMC, maximum material condition. So when I select, I'm also going to preset my GD&T tolerances, dimension tolerances, to set them to nominal, and I'm going to auto set the nominal diameter, and I'm going to go low, let's see, whatever the tolerance on this hole would be. We'll do plus or minus 2, minus 0.02, or 0.002, and high 0.002. And that will set my diameter tolerance on this when I select the true position. So now I've got tolerance, true position within 5 at M to datums A, B, and C. And I'm going to select true position, and then I'll click inside here to select these surfaces. Hit enter. And now SpatialAnalyzer recognizes that with a feature of size, you also need a corresponding diameter annotation. So instead of having to go back and create that diameter annotation separately, it will just automatically construct that for you. So I'll hit yes. And when I do that, you can see that SpatialAnalyzer has found the nominal diameter here, as well as added the tolerance which I specified, which is plus or minus 2. And the great thing about that is, as you go through and you inspect this, this gets a bonus tolerance for being inside its tolerance for its feature of size, and SA will automatically calculate that bonus tolerance for you. It's not something you have to add manually or anything like that. So that's the real basics of how to set up a GD&T inspection if you don't have model-based definition, if it doesn't come in automatically with the model. Let's go ahead and move to a job file that already has some data in it so we can talk about evaluation of these. And then I want to show you just a couple of use cases where you might have to do a little bit additional work in order to get the results that you want for specific datums. So I'm going to go ahead and open another job file. And if you have SpatialAnalyzer installed on your computer, all of these are available under the sample files section of the Help tab. And I'm going to open a sample file called GD&T with point clouds. And I really want to show off a feature of SpatialAnalyzer called Auto Filter. Okay, so this is a situation where we've got our CAD model, which we've imported here. And we've got all of our annotations, which came in from our CAD. Then we had our operator go out and scan the part, and you can see we have this nice pink point cloud. Let me go ahead and solid render our model. We've got a nice pink point cloud here, and we've got some probed points as well. So if you're a metrologist, you might be used to using a probe to be able to capture really good resolution data inside of a hole. And then you can use the scan to capture the surface data of your part as well. So this is a common way that GD&T is evaluated, using both probed points and cloud points. So it's great that we've got all of our annotations already selected, and we've also got some measurements. But the thing that we don't have yet is we haven't split up these measurements into the proper buckets. So you can see that we have our feature checks and our annotations here. And if I just scroll through these annotations, you can see that, let's see, datum 7. So this is datum D. It's right inside here in this hole. And you can see that it has the requirements all there, but it doesn't know which points go with datum D. Datum 6 in the tree here is this datum E, which is this circle here. If we keep on going down, we'll see datum A, which is the large surface there. Datum C is the side, and datum B is this back surface here. So we're ready to inspect this part, and we've got our inspection bar already set up here, but none of the data is in the appropriate buckets. And that's where an auto filter really makes a lot of sense. So you wouldn't necessarily use this if your operator had the job inspection ahead of time and they just went through the inspection bar, and as they measured, they just clicked through which datum they were measuring. But if you've got data that's already been measured and all you need to do is just dump it into the appropriate buckets, this is a great answer for that. So under the GD&T tab of the ribbon bar, we're going to select Auto Filter, and we're going to filter all checks. So this is going to put all of these point clouds into the right buckets, all of the probe data into the right buckets, instead of us having to manually do that ourselves. So let me switch back to wireframe just so you can see it a little bit better as this happens. And I'm also going to hide this pink cloud, and you'll see why in just a second here. So we're going to go Auto Filter, all checks. It asks us for our individual points. I'm just going to hit enter. I'm going to select these purple points as my point group, and as my cloud, I'm going to select that pink point cloud. There we go. So what this is asking is an edge filter setting, and just know that filtering points close to the edges is a good thing. It prevents the software from mixing up which points go with which edge. And in this case, what it's doing is just offsetting, looking off of the surface, first of all, for 1 millimeter, and an edge offset of 1 millimeter as well. That just avoids any data that might end up in the wrong spot. So we'll just hit OK. SpatialAnalyzer does its thing. It makes matching clouds for each point, and then I don't know if you can see how well you can see that based on my screen resolution, but if we bump up our pixel size there, then you can see that what the software did, let's go one more, there we go. The software did was it went into this large single point cloud, and using the CAD, it was able to split that point cloud up into the appropriate sections for each annotation. So in other words, it knows that datum A is this large top surface here, so it was able to filter out and use 11,000 points there for datum A. Datum B is this large surface here. It was able to filter out the point groups and also associate them as well. And then all of these other annotations that are in there, the software was able to use the CAD model to filter out all the extra data and figure out which goes in which bucket. And as you can see, I've already started evaluating. I can right click on feature checks and hit evaluate all checks. And then in just a few seconds, I think the streaming is slowing my computer down just a little bit, but in just a few seconds, we get all of our feature checks measured here, and we get pass-fail on all of them. So this is a really great way to have your model-based definition come in or create it yourself, and then not have to use a whole lot of time during your inspection, but let the software filter out what goes in what buckets for each thing. And then a great way to report out all of your feature checks is using a summary table. So I'm going to right-click on my feature checks, and I'm going to create an inspection summary table, which I think I already have one in this job file as well. But I'm going to include all of my feature checks and hit OK. And then under the custom report tables section of the tree, you can see I have one and then one that was created already. I have a report. I can add that to a report. And this is what a summary table looks like. So it's just a really concise way to show each feature check, the icon for what it represents, the tolerance, and then the high, low, and all of those things, pass, fail, and also the deviation in and out of tolerance. And then if you have a true position check, then you also get a direction error for the direction of deviation. So, and it shows up green for pass, fail. And then you get a great and then you get an indicator of that as well. Let me make sure that I'm just seeing that my mouse is not showing up in here. Let me fix that really quick. Okay, so I don't know if, can you guys see my mouse now? Oh, now the screen went black. Here, just a second. Okay, it's saying that it's capturing my mouse movements, and sorry if you can't see that. We'll work on that for the next webinar as well. Okay, so I wanted to do one more little example and just show you what happens when you have a part that's not so geometrically square and flat as this one is. I know a lot of you guys work in aerospace and in shipbuilding and power generation, and you don't always have nice flat surfaces to create your datums from. So we're going to open another job file here using sample files, which are built into your copy of SA as well, and this one is called relationships. So I'm just going to open this. And you see we have this, this job file here, which looks kind of like this speedboat. And so we've got the speedboat CAD. And again, we don't have any datums on here. So we're going to have to construct the datums ourselves. And then we have some data so we can evaluate the data as well. So I'm going to get rid of these relationships that are already in here. And I'm just going to hide our point groups so that they're not in the way while we're creating our GD&T, and I'm going to hide these planes, which will be useful here in just a second. We'll go ahead and set it to solid. Okay, so we've got a really organic type surface. So you can see that this flat surface, which you might use as a datum, is really the only kind of flat surface that we've got here. But we're going to use some of these curved surfaces as our datums. And I'll show you how to work around one of the requirements in SpatialAnalyzer for those datums. So first of all, we'll select CAD faces, pick datum A, and we're going to pick this large surface as datum A. For datum B, we're going to use both of these curved edges right here, and that's going to be datum B. So we'll be able to add data on both sides of these datums, and the software is going to fit to both sides using the datums almost like a slot. And I'll hit that, and then we'll hit C, and we'll select these two front points here because I know I have some data on there, and that's going to be datum C. Then we don't really have any features with measurements in this job file that have like a true position, but we do have a lot of data that we can use for a surface profile. So I'm going to go ahead and type in some surface profile feature checks, and we'll start with a 5 thou tolerance to A, B, and C, and we'll use surface profile. So we'll pick this top surface up here. So that'll be one of our surface profiles. We'll do another surface profile to this, which is actually our datum A. And then we'll do finally a surface profile on the edges over here, which is to datum B. And all of those are going to be within 5 thousandths tolerance. Okay, so we've got our datum structure set up. We've got some annotations set up. Let's go ahead and make feature checks here. So we made feature checks, and our feature checks include 3 datums and 3 surface profile checks. Let me just drag those out off the model just a little bit here. There we go. There we go. Okay. And save all. And now let me introduce my measured data back in. So again, if this was an inspection that you were sending to the floor, you would send the job file just like this, the template, and then the operator would just be able to add the instrument, connect to the instrument, and then just double click on one of these tasks in the task list to start trapping data to that. And you can see that as they start trapping data, the CAD face is highlighted for the area that they need to trap data. Then as we go to the next one, datum B, that area highlights, datum C, that area highlights, and so on and so forth until you've reached the end of your inspection. In this case, we already have data, but unfortunately our data is not aligned to our part. So I'm just going to create a real quick relationship alignment to this data so that we can use that really handy auto filter function to auto filter all this data to those CAD faces. So I'm going to go to our Features tab, which is where the Groups to Objects relationship is. And I'm going to select Groups to Object. I'm going to pick this group, this purple group, and the red group. And the object is, of course, our CAD model. And then all we need to do is just minimize these relationships. So I'm going to go to our instrument and go Locate, Minimize Relationships. And I don't know if you can see this window. It's on top. It's just our Relationship Minimize dialog. So I'm going to run optimization. And SA was able to solve it with a really good fit. 1 thou and 3/10 was our RMS on that. But now our data is fit to our CAD model, and we're ready to go and filter out this data to the appropriate checks and surface profiles. So if I go back to the GD&T and I select Auto Filter, just like we did before, filter all checks, select individual points, select point groups, and select point clouds. We don't have any clouds in there. Hit OK. And now we've got some measured data in here. Our feature checks, you can see, is showing 36 measurements, 56, and 66. But you'll see that it's giving us an error here, and it's showing that in order to evaluate these surface profiles, it needs offset geometry for datums A and B. And this is a very common thing that you see when you pick a datum in SpatialAnalyzer that has a curved surface. So the purpose of the datums is to control degrees of freedom. And if I show our planes back there, the purpose of the datum is to control our degrees of freedom. So when you have a curved surface, the problem is that it can obviously control degrees of freedom in more than one direction. So if you think about a curved surface that it's fitting like this, you know sort of intuitively when you look at that curved surface that what you're trying to control is the vertical direction. I'm trying to show this in the camera so you guys can see. You're trying to control the vertical degree of freedom. So you're trying to control your data like this. But because the surfaces are curved, it's also going to constrain you in this direction and in this direction. So it's going to constrain you in more than one degree of freedom. And all of that is fine. But what we want you to do in the software is be explicit about which degree of freedom you're trying to constrain. So if you're trying to constrain this normal to the surface degree of freedom, then we say, okay, create a plane in there that is the way that you want to constrain your data and constrain the data to that plane. And we call those reference objects. So if I go back to my annotation for datum A, you can see the datum A is the top of this part. What I'm really trying to do is control the fit in this vertical or Z direction. And so if this pink plane that you can see in the job file, that is in the Z direction. So I'm going to add that to datum A just by right-clicking on it and selecting properties. And again, I don't know if you can see this dialog box, but what it asks me for is SA offset objects. And so I'll select my offset object and then check to save that. And I'll do the same thing for datum B. So datum B is obviously controlling the left and right motion in this particular example. So I'll take my datum B and go to properties. And for SA offset object, I'll pick this green plane because it's going to constrain direction movement in that direction. And I'll hit save and close. And now if we go to our feature checks and evaluate all checks, did I save B appropriately? Oh, I need to update. Update existing feature checks. And now we can evaluate all checks. Oh, maybe I didn't save datum A. Okay, there we go. So now I had to make sure I saved datum A. So now we can see that with the SA offset object defined, we're able to evaluate these checks with the alignment to datums A, B, and C. And A is obviously constraining us in the Z direction here. B is in the X direction, and Y is B is in the X direction, and C is in the Y direction here. So now we're able to evaluate all of those using the correct SA offset object for curved surfaces. And you can see that obviously I put my my tolerances a little bit too tight for this particular inspection on the part. So yeah, so that's GD&T really in a nutshell. I know that there are some there's a lot more that goes into it when you're performing GD&T in a measurement situation. So we are always available at our website, kinematics.com. If I go back to, let's see if I can show you the website again. If we go back to the website, kinematics.com, you can click on support, and you can get directly to us with our support email, support@kinematics.com. There's also available to you is the essay community, and this is sort of a landing page for all of the articles and help articles that we have related to SpatialAnalyzer. So anytime you're looking for the information that we've covered here today, plus a lot more stuff, find that essay community on our webpage. And then email us directly. My email is caleb@kinematics.com. And I'm sure you guys all have, I know you all have application engineers that are somewhere close to you, no matter what part of the world that you're in, but we're all here and we're happy to help. So send us an email. Let us know what you think about the webinars. And let me go back to that. Let us know what you think about the webinars, and be sure to join us every Friday on the first Friday of the month. And we'll send out an email when we get a little bit closer to the one in March, letting you know what the topic is, and letting you come up with any questions that you might have before we actually do the webinar. So let me check the dialogue here to see if we've got any questions. And it looks like there are some problems with the mouse showing up. And okay, yeah, sorry about the dialogues not showing up there at the end, but we'll work that out. A little bit of problems here with the first webinar, but we plan to do them, so hopefully we'll get better at each one of those. So thank you guys for joining us online. Make sure to follow us on our YouTube channel and on our LinkedIn page, where we'll be posting these as well. But hope this has been helpful, and yeah, let us know what you think, and we'll catch you on the next webinar. So thanks for following along, everybody.